Okay, we'll start at 8 a.m. in about 4 minutes. Michaela? Howie? It's going to take me a while. Chloe? Taylor? Ariana? Brianna? Anissa? So Alexander? Chloe? So Holly Mickelson is not, oh, that's you. Okay. Jessica. Go ahead. I think I called all the names. Oh, I got it. Off to a great start. Hey, if you're online, go ahead and sign in if you're watching by YouTube. Okay, it's 8 o'clock. Today we'll cover the first part of the next section, 2.6, on how to solve compound inequalities. Well, I did point out examples of compound inequalities last week, but today we'll cover them in more depth. A compound inequality is made up of two inequalities connected by the word and or the word or. To begin with, compound inequalities made up of two inequalities connected by the word and will be covered. So consider the following example. So as far as I could tell, officer, the burglar was taller than 70 inches and shorter than 74 inches. So if we say we want X to represent the height of the burglar, I'll just label that X as the burglar's height. Then we can write a compound inequality. So the burglar was taller than 70 inches and shorter than 74 inches. So we could write 70 is less than x, and at the same time, x is less than 74. This is the more compact way to write it, which is what we want to do. But you could begin with writing the burglar was taller than 70 inches and shorter than 74 inches. So those two expressions are equivalent, but in this case, at least in algebra, this is the more compact and more concise way to write that inequality. 70 is less than x, and at the same time, x is less than 74. Okay, so the two inequalities are connected by the word and, or if the two inequalities are connected by the word and, then only numbers that satisfy both conditions are satisfied. So there are, if you just considered x less than 74, well, 68 is a number that's less than 74. But when we're using the word and, a number x has to satisfy both conditions at the same time. Not only is x less than 74, x is also greater than 70. That's why the word and is used. It satisfies both conditions at the same time. Okay, the next paragraph. Two inequalities connected by the word and mean that the intersection or overlap of the two inequalities consist of the numbers that satisfy both conditions. So I'll try to squeeze in a little graph here. I'll draw two number lines. So on the top one, I'll graph x is less than 74. So x is less than 74. We saw last week, if we're just looking at x less than 74 by itself, then it goes from negative infinity up to 74. Then on the other one, 70 is less than x, but that's equivalent to writing x is greater than 70. So if 70 is down here, and if x is greater than 70, then it goes to the right, positive infinity. Okay, and when we're using the word and, the overlap is the set of numbers that we want. You see what I mean by overlap? If you were to look at the parts of the two number lines that have the same numbers, they are only the numbers between 70 and 74. That's the overlap. I can draw a bigger picture of that later if that's necessary. I'll probably do that a couple more times just to get the point across. Okay, two inequalities connected by the word and mean that the intersection or overlap of the two inequalities consist of the numbers that satisfy both conditions. Okay, so the interval notation, we'll get to that in a minute, but with interval notation, the symbol, it looks like an upside down U. It's not really a U, it just sort of looks like a U. But this symbol is used for intersection with interval notation. Okay, so up here, let's look at the two inequalities separately again. Suppose I write x is less than 74 and x is greater than 70. Do you remember the interval notation for x less than 74? I alluded to that a couple of minutes ago. The interval notation for x less than 74 is parenthesis negative infinity comma 74 parenthesis. The interval notation for x greater than 70 is parenthesis 70 comma positive infinity. And down here we're saying that we're using this symbol for the intersection, which is what the word and implies. So I could put the intersection symbol between those two sets of numbers. And that is one way to write those numbers. It's the intersection or the overlap of those two sets. Okay, but this can be written more compactly, which is what we want to do, especially in Newton. It's not that this is incorrect, it's just that it can be simplified a little bit more. And we can see a picture of that above. Up here we see the overlap is the interval from 70 to 74. Okay, so this set, the intersection of this part of the number line with this one, we want to write it as parenthesis 70 comma 74 because this is the overlap. Those are the numbers that are in both sets. You see how that works? So this corresponds to the graph that I had up there. Up here, x is less than 74. This is how we would graph it. The bottom graph is x greater than 70. And the overlap, the place where the numbers are the same on both sets, are just from 70 to 74, excluding the endpoints. Okay, well, we already did it, but we'll do it again, just for practice. Write the algebraic notation and interval notation for the compound inequality above. Okay, so I'll rewrite this. X is less than 74 and x is greater than 70. So we know what is meant, but with this algebraic notation, this can be written more concisely. X is less than 74 and x is greater than 70. The way that we want to write it is what we already saw above. We want to write it as 70 is less than x, which is less than 74. So this is the algebraic notation that we want to write in this case. That is the overlap of the two sets. And as we already saw, I'll just do it again. This set of numbers, x is less than 74. That's negative infinity, comma, 74 parenthesis. The word and means intersection or overlap. So we put the intersection symbol, and then x is greater than 70, we put parenthesis 70, comma, infinity. But this can be written more concisely. The overlap in interval notation is parenthesis 70, comma, 74. With interval notation, we want to make sure that the smaller numbers are to the left and the larger numbers are to the right. Okay, let's look at another statement involving the burglar. Okay, this time it says the burglar was at least 70 inches tall and no taller than 70 inches. Well, if the burglar was at least 70 inches, then the burglar could have been exactly 70 inches or taller. So this part, if we use x to represent the burglar's height, we could say x is greater than or equal to 70. And the burglar was no taller than 74 inches. So the burglar could have been 74 inches tall, but no taller. So we would say x is less than or equal to 74. So the way the inequalities are described will indicate whether you use the or equal to part or not. Okay, so since it's and, that means the overlap. So this compound inequality in algebraic notation, we would write it as 70 is less than or equal to x, which at the same time, x is less than or equal to 74. Okay, the interval notation, x greater than or equal to 70, we put a bracket 70 bracket 70. I need to adjust this a little. Okay, bracket 70, comma, infinity. The word and is used, so overlap or intersection. And then let x is less than or equal to 74, we put parenthesis negative infinity, comma, 74 bracket. But we can write this more compactly. The overlap is the interval from 70 to 74, including 70 and 74. That's why we're using brackets in this case. Okay, let's move on to the next page. So something to be aware of. I'm writing it as a warning. A compound inequality made up of two inequalities connected by the word and may be impossible. So here's another example involving the burglar. The burglar was shorter than 70 inches tall and taller than 74 inches. So the police officer would probably look cross-eyed at the person who described the burglar that way. Well, it's impossible for the burglar to be shorter than 70 inches and at the same time taller than 74 inches. Okay, if you write it in algebraic notation, we could say, well, let's see, shorter than 70, so x is less than 70, and x is greater than 74. If you draw each of those, if you sketch the graph of each of those, you'll discover that the overlap, there is no overlap. So if we have 70 here, if x is less than 70, it's to the left of 70 on the number line. The other one is x is greater than 74. So that's to the right of 74. There's no overlap. Nothing is in the overlap. There's no intersection. You can write it in interval notation. X less than 70 is negative infinity to 70. And then it means intersection, so we use the intersection symbol. X greater than 74, parenthesis 74, comma, infinity. But there are no numbers in that intersection. So let's read the next couple of statements, and then I'll write down how we would express this intersection. If two sets of numbers do not overlap, then the intersection of the two sets is empty. So in this case, the intersection is the empty set. The empty set is just the set that doesn't have anything in it. The mathematical symbol for the empty set is a circle with a slash through it. Okay, so we could say, well, since there's nothing in the intersection, then this is the empty set. So you'll see this symbol in Newton when you're working on inequalities. Okay, let's look at a few examples involving intersection. Okay, we'll look at the following compound inequalities using algebraic notation and interval notation for these examples. Okay, x is greater than 3 and x is less than 5. Let's do the number line exercise. You don't have to do it this way all the time, but it might help to start with. So the top one, x is greater than 3. So on the number line, it's just the numbers to the right of 3. The other one is x is less than 5. So on the number line, that's just to the left of 5. And the overlap, or the intersection, well, the overlap is just from 3 to 5, and just everything in between 3 and 5. I'm using parentheses instead of brackets because both inequalities are strict inequalities. They're just, one is greater than and the other one is less than. The algebraic notation should be written so that it mimics, in a way, the graph. So the algebraic notation is 3 less than x less than 5. So this is saying 3 is less than x and x is less than 5. That's what we're given over here. 3 less than x is equivalent to x greater than 3, right? That's the algebraic notation. The interval notation, you can also use the graph to help you with the interval notation. The interval notation is parenthesis 3 comma 5 parenthesis. It is true that the interval from 3 to 5, excluding the endpoints, it is true that that is the intersection of negative infinity to 5 intersected with the interval from 3 to infinity. But as we've seen, this, in this case, should be written like this. Even though this is not incorrect, in the software, in the Newton software, it will require this answer instead. It's the more concise way to do it. Okay, so the examples we'll look at are going to be, some of them will be similar, just with different symbols. So sometimes we'll use brackets, sometimes we'll use parentheses, sometimes we'll use a combination, but it's all determined by what we're looking at. Okay, x is greater than or equal to negative 4 and x is less than 6. So we'll do the number line overlap method. If x is greater than or equal to negative 4, so we have negative 4 bracket and shade to the right. To the right means greater than. The other one, x is less than 6. So 6 is to the right of negative 4. Okay, this time we'll use a parenthesis that opens to the left, and then we shade to the left. And the overlap, well, the overlap is going to involve the numbers negative 4 and 6. So we have a bracket at negative 4, a parenthesis at 6, and then the numbers between also. Okay, we don't always have to go into as much detail as we've been doing. If you want to see more detail, you can ask for it. But this graphical method can help us write down both the algebraic notation and the interval notation. So the overlap is from negative 4 to 6, including negative 4, but excluding 6. So the algebraic notation is negative 4 less than or equal to x, and x is less than 6. This is the algebraic notation. The interval notation looks a lot like the graph. We just put a bracket on the left, negative 4 comma 6 parenthesis. So this is the same set of numbers in interval notation. Okay, we can probably pick up the pace a little bit if you're catching on. Okay, x is greater than 0 and x is less than or equal to 10. I'll still do the graphs. Two different number lines. If x is greater than 0, then we have a parenthesis at 0 and shade to the right. If x is less than or equal to 10, bracket at 10 and shade to the left. And the overlap, so the numbers 0 and 10, the overlap, we have a parenthesis at 0, a bracket at 10, and we shade everything in between. The algebraic notation, x is a solution if x is a number in this set. So the algebraic notation, 0 is less than x, and x is less than or equal to 10. This is the algebraic notation. The interval notation, parenthesis 0, comma 10, bracket. So a parenthesis corresponds to an inequality without the or equal to part. A bracket corresponds to an inequality with the or equal to part. Okay, more of the same. Okay, this one, x is greater than or equal to -5 and x is less than or equal to 7. So we'll do the number line overlap method. So x is greater than or equal to -5. So from -5, we put a bracket shade to the right because it's greater than or equal to. X is less than or equal to 7, so we put 7 bracket and shade to the left. The overlap or the intersection are the numbers from -5 to 7, including -5 and 7. So that's the overlap. And then the algebraic notation. So a number x is in the set if it's between -5 and 7, and it could be -5 and 7. So the algebraic notation is -5 less than or equal to x, and x is less than or equal to 7. This is the algebraic notation. The interval notation, bracket -5, comma 7, bracket. Okay, the next one. Okay, the next one, x is greater than or equal to 2 and x is greater than or equal to 4. So let's do the number line overlap method. X is greater than or equal to 2, so we start at 2, put a bracket, and shade to the right. The other inequality, x is greater than or equal to 4, so 4 is to the right of 2, but since it's greater than or equal, we shade to the right. Hey, where do the numbers, or where do the lines overlap? The only overlap is from 4 to infinity, right? This other part does not overlap. You see that? If you only want the overlap, it's only where both sets are the same. So the overlap is just from 4 to infinity. You see that? So this is one of those twists. It's completely logical, but it can, if you don't see it ever, then it could cause a little bit of confusion at first. Okay, so the algebraic notation is just x is greater than or equal to 4. That's the overlap. And so the interval notation is bracket 4, comma, infinity. Okay. The next one, x is less than 1 and x is less than 8. So we'll do the number line overlap method. Since and means intersection, that means overlap. Hey, if x is less than 1, that's parenthesis open to the left, shade to the left. If x is less than 8, it's parenthesis at 8 and shade to the left. What's the overlap for this one? The only overlap is to the left of 1, right? That's only where they overlap. Okay, so the overlap is to the left of 1. That's the intersection. Okay, so this is the overlap. So the algebraic notation is x is less than 1. That's it. That's the algebraic notation. The interval notation is negative infinity, comma 1. Also correct, but not considered simplified enough. If you use the intersection, x less than 1, that by itself in interval notation is negative infinity, comma 1, parenthesis. The word and means intersect, overlap, and then x is less than 8 is parenthesis negative infinity, comma 8, parenthesis. So although, as I have mentioned a few times, although this is correct, mathematically it's correct, you'll need to write it more compactly when you're answering questions in Newton. Okay, let's do this one. X is less than or equal to 3 and x is greater than 5. So we'll do the overlap method. If x is less than or equal to 3, then graphically we put a bracket at 3 and shade to the left. On the next line, x is greater than 5, so 5 is to the right of 3, so we put a 5, parenthesis, and shade to the right. And what part overlaps? Yeah, there's no overlap. They don't overlap anywhere, no overlap, or no intersection. Or more formally, we say the intersection is empty. Intersection is empty. So the interval notation for the empty set is the symbol for the empty set. For algebraic notation, you would just say no solution or nothing, whatever the option is. Okay, we'll look at a few examples that are a little more involved, but they will boil down to some of the examples that we've already seen. This will just require a little bit more algebra. So this one, negative 2x is less than or equal to 12, and 3x plus 6 is less than negative 3. So all we have to do is solve each of the two inequalities separately until we get x by itself in each of them. And then we'll do what we did in the previous examples. So on this one, negative 2x is less than or equal to 12. When we solve this for x, what are we going to get? Well, we can divide both sides by negative 2, but keep in mind, whenever you divide both sides of an inequality by a negative number, you have to switch the inequality to its opposite. The same as, you'll do the same thing if you multiply both sides of an inequality by a negative. Okay, but here we just want to divide both sides by negative 2, so we're going to write this as x greater than or equal to negative 6. Okay, so the one on the left that's as far as we can simplify that. Then we have two steps for the one on the right. 3x plus 6 is less than negative 3. So first subtract 6 from both sides, and we get 3x is less than negative 9. I'll rewrite the one on the left, even though it's complete. X is greater than or equal to negative 6. And this one, we divide both sides by 3. We get x is less than negative 3. Okay, then we want to write the algebraic and interval notations for the solutions. So I'll reiterate, we're solving the following compound inequalities. So write the solutions in algebraic notation and interval notation. So if you want to do the graphical overlap method, we can. Okay, if x is greater than or equal to negative 6, then negative 6 on the number line, put a bracket and shade to the right. On the other line, if x is less than negative 3, negative 3 is to the right of negative 6. So this, we have a parenthesis at negative 3, and we shade to the left. The overlap from negative 6 to negative 3, we have a bracket at negative 6 and a parenthesis at negative 3. Okay, so there's an overlap that's not empty. The algebraic notation, we write negative 6 is less than or equal to x, and x is less than negative 3. This is the algebraic notation. The interval notation, bracket negative 6, comma, negative 3, parenthesis. Okay, the next one, same exercise, same kind of exercise. X plus 5 is greater than negative 3, so subtract 5 from both sides. We get x is greater than negative 8. On the right-hand side, a couple of steps. Add 5 to both sides, so we get negative 2x is less than or equal to 6. The one on the left is already finished. X is greater than negative 8. And this time, on the right, we divide both sides by negative 2. So negative 2x is less than or equal to 6 is equivalent to x is greater than or equal to negative 3. Okay, let's try the graphing those and find the overlap or the intersection. Okay, negative 8 is to the left of negative 3 on the number line. So if 8 or if x is greater than negative 8, we put a parenthesis at negative 8 and shade to the right. And then on the next one, negative 3 is to the right of negative 3. Sorry, negative 3 is to the right of negative 8. X is greater than or equal to negative 3. We put a bracket at 3 and shade to the right. So where is the overlap? The overlap is just from negative 3 to the right. You see that? Okay. So we could, well, let's write the algebraic notation first. The algebraic notation is just x is greater than or equal to negative 3. The interval notation for this is bracket negative 3 comma infinity. So this is the way that we want to write the interval notation. But it's equivalent to x greater than negative 8. That's parenthesis negative 8 comma infinity. Intersect or overlap, x is greater than or equal to negative 3 is bracket negative 3 comma infinity. Okay, but we'll want to write it more compactly, bracket negative 3 comma infinity. Okay, one more. So 3x minus 2 is less than 4. Add 2 to both sides, so we get 3x is less than 6. And on this one, subtract 11 from both sides, we get negative 2x is less than negative 10. On the left, divide both sides by 3, we get x is less than 2. And this one, we divide both sides by negative 2. So we switch the inequality from less than to greater than. Negative 10 divided by negative 2 is positive 5. Okay, so the graphical overlap method, if x is less than 2, parenthesis shade to the left from 2, if x is greater than 5 on the other number line, 5 and shade to the right. So there is no overlap. So no overlap. So we say that the compound inequality has no solution. The interval notation for no solution is the empty set. That's the empty set. Okay, so we got through all of the notes that I wanted to today. So I guess that's all for now. If you have a question about something that you want to ask, you can do that for a couple of minutes. I'll also work on the attendance. Good.
So on this last problem, when we divided the 3 from the 6, should we switch the sign to x is greater than 2?
When I divide both sides by 3?
Yeah.
No, since I divided by positive 3, the inequality stays the same.
Okay, it's just.
It's when I divide both sides by a negative that I have to switch. And there's another way to do it. If you have negative 2x is less than negative 10, if you add the 2x to both sides and add 10 to both sides, then you'll get 10 is less than 2x. And when you divide both sides by 2, you'll get 5 is less than x. But 5 less than x is equivalent to x greater than 5. Does that make sense? Okay, so I guess that's all for today. Let's see, Ariana Butler. Hi, Dang, Jose Fabilla. Jose. Anissa Fountain. Isabella Holt. Jacob Morgan. Richard Van Leith. Joseph Vaughn. Okay, that's all for today. Okay, I'm going to end stream. I got everyone's attendance, I think.